Welcome to Moving Analytics to the Cloud. We're going to have a short introduction about this topic, and then I'm going to introduce a couple of other persons. So welcome very much to this topic, and hope it's going to be good. We're going to be 3 different persons who are going to talk today about this. It's going to be me, Michael Forsberg. I'm a senior cloud advisor. I've been working quite a lot with Google Cloud and other cloud platforms as well. And then we're going to have Filip, who's going to introduce and talk a little bit about customer cases. And we're going to have Christian, who's also going to give you lots of good things about moving the analytics to the cloud. So, moving analytics foundation into the cloud. What it's all about, and why are you looking into this? We have seen that lots of our customer is today looking to moving from on-prem solutions more and more into the cloud. So it's going to be something that's going to take up to speed quite fast. But it's quite important to understand that we are in the early stages here. Mostly of all things that are done today in the IT is done on-prem, and there is not so much of it that's done on the cloud. But the speed is taking up quite a lot. But it's in early stages and it's going really, really good. So I think it's something to look into. What you need to have in mind also is that traditional data warehouse solutions and data solutions are still, the foundation is still on traditional solutions, like on-prem and so on. But moving into the more modern solutions like you can use in the cloud is something that's going to get your speed and going to get more innovation from it. And what we see from our customers is the first steps to do this is always looking into some specific data pattern or data sets or analytics specifics that you would like to dig into and look more into the new analytics environment. So we see typically customers who like to test these kind of things, and the data and the data warehouse modernization, I think, is the first thing to do. What you see there is the breakdown silos, and it's increasing the speed of innovation, and you get lots of things from the platforms that you didn't get from only having the data stored in silos or on-prem solution. And what also the cloud providers are telling us is that they see that their implementation in the cloud is also giving you lots of things that you couldn't have when you have it on-prem. And it's breaking down silos, utilize faster network speeds, and enable more powerful analysis. And all of this to lower cost. And I think what we have seen is you're getting much more speed also. So you don't need to take care of all the tech things, or you can do it in a small laboratory way of doing things and verify if it's work. And if it doesn't work, you can throw it away. What I would send to this as a recommendation is when you're moving your analytics to the cloud, it's thinking about how you deliver this cloud journey and what promises you send. Because we have seen lots of examples when you're maybe sending more promises than you can keep. So try to keep it a little bit shorter and be very specific what you're gaining for, what you're trying to achieve to both to your customers and both to your internal persons. Now what would I like to end with is starting from the right perspective. And when we come to that, it's like naturally you would like to deliver business value. That's what everybody would like to do. So you need to have a clear view of how you deliver your business value. But what we have seen is that many start from a technology perspective, and they're trying to convince persons or companies that what technology to use to achieve this business value. But what's really important is that you also understand what strategy you would like to accomplish and what business model and what you would like to solution you would like to do. So when you combine these 3 things together and coming together from the right perspective is to describe what technology that enables the strategic initiatives is the main thing. So you can gain the business value from that. And I think it's time to let Filip and Christian to talk a little about how you use Google and BigQuery to modernize your data warehouse and get the real-time business insights.
Thanks, Michael. One thing to keep in mind when working in GCP or similar cloud environments is that it's a new thing that got potential. It's not simply a tool that can replicate your current solutions and put them to the cloud, but rather a way to enhance these solutions in a manner that fits your needs. For example, let's say you have many different Excel sheets circulating around this organization, a situation I'm sure many of you can relate to. One way to utilize cloud is to simply automate this circulation by ingesting the data, calculating measurements, and distributing Excel documents to the recipients. But this may not be the best solution. Maybe you want to visualize some of your measurements in other ways than just numbers and tables in static sheets. Maybe you want something interactive. Instead of having 5 different sheets in one document showing the same things for different departments, you want one report that filters by departments instead. Maybe you want to do some analysis on the data and visualize that as well. Or maybe you want to integrate data from other sources into the reports as well to create new measures. You can obviously go on and on here. This brings us to a new kind of way to work with data. Let's say you have this solution. We don't need to get into all details here, but let's say you have identified a way to distribute data from 2 sources out to some users via a company-wide data warehouse. As time passes by, maybe you identify another use case and want to distribute data to another group of users. Starting from the right here, you can look into your data warehouse to see if you already have the data you need. If you do, you can take what you need and do the calculations and transformations you need and then distribute the data. If you don't, you need to figure out what data you need and how you can integrate that new data. Let's say you need to integrate yet another data source. As you can see to the left, there are different ways to do that, and you need to identify a way to ingest the new data that works for that data source. Maybe this can even open up a new way of working with the data source as well. When the ingestion is done, you can integrate the data into the data warehouse. By doing this, you make things easier for the people developing the next use case, just as the approach from use case 1 helped the developers for use case 2. Another thing we have learned when working in the cloud is that it's an iterative process. Last week, when Christian and I discussed this, we drew parallels to the smartphone. We all know that the apps get updated once in a while. Most often, the updates are very small. What I'm trying to say is that any given application on your phone never really gets finished. There's always things to improve and functionality to add. It's basically the same thing with your solutions in the cloud. Rather than thinking like it's an actual smartphone, where, for example, iPhone 11 has a clear release date, and when it's done, it's done. Cloud solutions are a work in progress. If we look back at the example from the previous slide, when a use case is first presented to selected users, it's more like a beta version of a smartphone application, not the finished product of the smartphone itself. We think this is a powerful mindset to have in the organization when working in the cloud environment. This is also where you can enhance your current solutions, as I mentioned earlier. Working in this way, you can involve the users in the development to catch their ideas of improvement. Some of them may not like working in Excel at all. This brings us to our next topic. To be able to succeed in the cloud, you need to synchronize your stakeholders. This picture you have seen before, and now I have added circles which represent the different stakeholders from a recent project. Each of the 2 data sources has their own expert. Then we have my colleague Christian, who did the ingest parts of the project, and then me, who built the data warehouse and data marts in BigQuery. And then we had the representative of the users. So this project is in an early stage with only 5 stakeholders. But as the system gets bigger, you get more stakeholders, and some of them will, of course, change along the way. Either way, it's important for all stakeholders in this example to be aware of changes happening that can impact the whole solution. For example, if something is changed in data source 1, whether it's a new field in the data or a complete overhaul of the structure, the others need to know about it and adjust. The people working with this data source may be used to work in a certain way, and you may have to make adjustments, for better or for worse, for it to work with a new cloud integration. There are things you can do to maintain control of the system and handle changes in input data. Christian will talk more about that later in one of the quick tips. There can also be a change in the organization from the user side to the right in the picture that we need to know about. In this example, we have a permission structure among the users, and if that structure is changed in any way, we need to know about it and adjust that structure to make it work. Another thing to keep in mind when working in cloud is that there's many different ways to construct your system. The example we have shown is just one part. As you can see there, the data sources are ingested in different ways. There could be multiple reasons for that. You obviously need to take into account how the source data is structured and how you can ingest that data in a manner that works best for you. There isn't a one solution fits all here, even though there are guidelines and best practices. And as the cloud environment is still quite new, these best practices change continuously. So it's important to keep up with the new technology that your platform is providing. Also bear in mind that this applies to both solving smaller problems, as how to ingest data from an external data source, as well as how to best construct the whole cloud system. And that wraps up this part. So now it's time for the 15 quick tips. The first tip is to use project fragmentation. Projects are a very useful way to contain coherent components. In this example, an expert on data source 1 can work in a separate project without disturbing other parts of the system. Data source 2 may need entirely different components to ingest, so there isn't really any reason to hold them together in the same project. It can also help in maintaining a clear overall structure. Using project fragmentation, users and user groups can be involved in only those projects they need to be involved in. For example, one user can be a project owner in use case 1, while having read-only permissions in the company data warehouse project. It is also useful when debugging. If something goes wrong, you can get a handle of it faster if you can limit the number of possible sources of the error. Number 2, Google Cloud and cloud in general provides you with different ways to solve problems, as we mentioned earlier. You can utilize this to create flexible development solutions. If you maintain a module-based structure from the beginning, you can create development environments based on the need in question. For larger features, it may be best to keep a dev version of an entire project, while for minor features, it can be enough with a smaller component. For example, if you want to optimize a view in production in BigQuery, you can keep a dataset as a sandbox environment, where you can work on your view with production data without disturbing the other views in production. You can basically create small dev environments when you need them and then delete them when you're done.
Next up, we have the heart of the data warehouse solution in GCP, and that is BigQuery. And that is not your traditional database, even though it has the tables, the views, and the standard SQL syntax. It's really optimized for handling huge amount of data and then doing queries against that. It's a fully managed system from Google, and it scales to multiple petabytes. But the key thing is that BigQuery doesn't slow down when you add more data. And this is because it takes your SQL query and converts it into a job that it can then distribute over the Google infrastructure on many nodes. And then it can collect all the results into a new table. And that gives you a consistent performance without the need for traditional indexes. A common way to do ETL in GCP, to get the data into BigQuery, is by using a service called Dataflow. And Dataflow is a fully managed batch and streaming data pipeline from Google. And it offers horizontal scalability, and it can run jobs that is created with the open source Apache Beam SDK. And you can use ready-made templates, or you can write your own using Python or Java. And Dataflow is perfect for doing ETL, like both the your batch jobs that you would traditionally do with Hadoop, or with real-time streaming jobs. So you really have one tool for all your different kinds of ETL jobs. And another use case for Dataflow is for machine learning. Another great building block that can be used together with the Dataflow is something called the Apache Airflow. And it allows you to create pipelines and orchestrating different tasks. It allows you to, for example, look for a new file, and when this new file appears in a storage bucket or gets updated, it can spin up a Dataflow job to transform and load that file into BigQuery. And Google offers a fully managed implementation of Airflow in GCP, and it's called Cloud Composer. And this is because Airflow can be a bit tricky to set up. There's a lot of moving parts, and Cloud Composer will take care of that for you. It will give you a Kubernetes cluster with Airflow installed. It will set up a required SQL database and a web interface to administrate it. It will also integrate with the Google Stack driver to give you logging and monitoring in the same way as all the different GCP services.
Yes. Number 6, when you have data in BigQuery, there's multiple ways to interact with the data. You can use Google's own tool, Data Studio, to quickly get going with analyzing your data. It is also possible to connect the data to third-party software like Power BI or Tableau, or to further explore the data. If your company already uses any of these tools, it makes it easier for the users to adapt. These integrations make it possible to create reports and distribute them at a large scale throughout the organization. Here it is important to keep in mind the organizational structure and define users and groups in a way to obtain a solid permission structure.
So what does it cost to run the data warehouse in GCP? One concern that we noticed with several projects is about, there's one thing to move the data into the cloud, but what does it cost and what drives the cost? Because in GCP, the cost structure is not what you would typically find in your traditional system, like with Oracle, for example. So there is no license for running it. So it's entirely based on, resource usage. The storage in BigQuery specifically is very cheap, and you even get the first 10 gigabytes for free. But a thing to note is that you pay for all data being processed. So if your query returns one row, you still need to pay for all the data it had to go through to find that row. But here as well, you get a bit for free. So you get 1 terabyte of processing per month, and then you pay as you go. But even though the cost might be low, there's still ways to optimize it, and I will talk about that a bit further. But from our experiences, it's not really the data warehouse itself that has the biggest cost. It's with the ETL pipelines. So if you have streaming pipelines running all the time, like processing data to put into your data warehouse, that's usually where the cost is. To really support an iterative development, you should use something called infrastructure as code. So that means that instead of creating everything manually in the UI, clicking and modifying things, even though it's super tempting, and then try to document it and keep that up to date, you should use a tool that allows you to define all the resources and infrastructure in a code, and that way you get the documentation for free. And it's always up to date, and you get a reproducible environment. So you can quickly throw up a duplicate environment for testing, for example. And a really great tool for this is Terraform. It's from a company called HashiCorp. We use that in a few projects, and it's been super helpful. And it works great with all the different components in GCP, and it even comes pre-installed in the Google Cloud Shell. Yes. So now, when you have your environment provisioned and so on, you have to think about, security and how to isolate it. And one way to do that is to put the resources and the different tables or parts of your data warehouse in different projects and set permissions that way. Filip touched on that a bit previously. But in most cases, you want to have, even finer granularity. And that's where the datasets come in. So dataset is a collection of tables and views, and you can set policies on who can do what with those tables and views in that dataset. And Google actually launched column-level security in beta just a few weeks ago. And that also allows you to set the policies on specific columns in tables. It's also possible to get row-level security, but that is a bit more complicated, but it is possible. And a general best practice in GCP is to use the principle of least privilege. So you would only get permissions that is, just enough to do the job required. And you should always, give the permissions on a group level, so not to individual users. So that way, it's much more manageable, and you will have a lot less headache in the long run. I promise you. So now, when we have, possibility to provision and to set the permissions, we also need to think about, how to make the data warehouse resilient. Because there will always be things that stop working, APIs become unresponsive, your source systems might change, the schema might change, there will be things that change. So you should really allow for failure. And one way to do that is also to allow for duplicates. So you can, rerun a failed job with confidence, because, rerunning the job, you have the risk of having duplicates. So you should really, allow for that. And one way to do that is to use views in front of your ingestion tables to just filter out, those duplicates. And this is especially important when doing infrastructure as a code, because you want to have a reproducible environment. And you want to, have it working all the time. And another thing to think about, when doing that, is to exactly specify the versions of different dependencies. So in your Airflow jobs or data flow jobs, you should specify exactly what kind of versions you want, so that when you rerun it, 6 months from now, you know that the combination of dependencies will work in your setup. We had a few cases that we noticed that things stopped working, and that was because a new version of a dependency behaved a bit differently than previously. And as mentioned before, BigQuery is not your typical database, and the queries pretty much run across the entire table. And even though it's distributed, there is still, a slight performance impact, but mostly it's a cost impact, because you, of course, pay for all the data that is being processed. So one way to mitigate that a bit is by using partitioning. So partitioning is, as it sort of implies, is that you would partition the table into sort of hidden tables. So one way to do that is to do it by date, for example. It can be create date, modify date, ingest date, or you can use other things as well. So in the background, Google will place that data into like different hidden tables. So when you do a query, it can figure out like which sort of subsets of the data that needs to be processed, and you only pay for that. And there's also, the performance impact on that as well. There's less data that needs to be collected and orchestrated. And a sort of a additional thing you can use with partitioning is clustering. So clustering is kind of a sorting. So data that is relevant gets placed together, so it's quicker for Google to, process that and find that. So if you have queries with filters where you have like, let's say you have a business unit, so like that would really allow you to speed things up.
Yes, a powerful feature in BigQuery is scheduled queries. They are useful when you have complex joins in your views and need to materialize your data into tables. In this example, we have a table that is updated once every 24 hours. As BigQuery isn't a traditional relational database, the best uses for these queries are to truncate or append to tables. One nice feature for these queries are the synchronized schedule. As you can see under the schedule, it says every 24 hours synchronized. Synchronized in this example means that the query will run at midnight Swedish time. In the same way, every 2 hours means that it will start at midnight and then run again every 2 hours. This makes it easy to keep track of when the data was last updated. Scheduled queries can be created in the graphical user interface as well as provisioned using Terraform. One interesting feature is to use Google Sheets as data source in, for example, BigQuery. In a recent project, we figured we needed a better way to input data manually to the system. So we created Google Sheets documents for this purpose and connected them to BigQuery. This makes it easy for someone without the GCP expertise to insert data into the system. It is pretty straightforward, and you can do it right in the graphical user interface as well as provision it using Terraform. Google Sheets is an application outside of GCP, so here it's important to keep a permission structure in mind that works. Permission can be controlled in different ways, for example using AD groups. Another neat way to input data into GCP and BigQuery is using Google Forms. This enables even more people to input the data to the system. Forms can be used externally as well as internally to collect information from a large number of people. The results can be stored in Google Sheets, which can be connected to BigQuery as I described earlier. We have used these as a commenting function in a project recently. There we have a distributed Data Studio document, which includes user input comments that are connected to the data. As these comments can come from multiple people, we decided to use forms instead of using sheets directly, as this can get quite messy if many people write directly in the document. As some of the values are connected to filters in the report, we need to control that these values we get have the right format. It is important to keep in mind when using forms, to formulate the questions and to utilize the functions there to get the format you want.
So last point. And now when you start to ingest a lot of different data into your data warehouse, you might have data from CRM systems or from marketing systems. There could be a concern about privacy, especially in the EU with the GDPR, because you will start ending up having sensitive information in your data warehouse. But Google has a really cool tool that can help you with that. It's called the Data Loss Prevention Service, or DLP for short. So it can use different filters and methods to detect sensitive information. So it can be like personal numbers, it can be phone numbers, it can be age, it can be occupation, and so on. So the DLP allows you to sort of tokenize it, mask it, or like reduce the accuracy of it. So if you have a job title, you might have chief engineer. It can change that to engineer, which is a bit more general. And you can also use this together with Google Key Management Service. So you can encrypt different rows, and you can encrypt the sensitive data using encryption keys. And if a user wants to be forgotten, you can sort of delete the encryption key, and that way you can't retrieve the sensitive data anymore, but the data that wasn't sensitive for that user can be retrieved. So that's like a really simple way to be able to comply with regulations and or help you to comply with regulations. And to simplify things. So that was the last point, and I hope some of it has been useful, and thanks a lot for me.